Okay, now we're going to learn something called an inverse trigonometric functions. We know what is an inverse function. That's what we learned in earlier sessions. And then we know what trig functions, sine, cosine, tangent, cotangent, secant, and cosecant. Now, what is an inverse trig function? We're going to learn them one by one. First of all, let's do a quick review about the inverse function. If you have f of x equals 2x plus 1, can you find the f inverse of x? And that's what we learned in much earlier. We first talk about the inverse function. There are magic 4 steps, right? Step 1, rewrite f of x as y. So you get a y equals 2x plus 1. Step 2, swap x and y. So change all the y to be x, change all the x to be y. Step 3, solve for y. In this case, you just minus 1 divided by 2. So you get x minus 1 over 2. Or x over 2 minus 1/2. Step 4, rewrite that as f inverse of x equals x over 2 minus 1/2. So that's 1, 2, 3, 4. Magic of 4 steps to find the inverse function. This is the review. We learned this a time ago. However, and we know something else. If two functions, they're inverse of each other, then the graph of that will be symmetric along the 45 degree. So which is, if you have, this is x, here's the y, and this is your 45-degree line, which is y equals x. This is y equals x, okay? So here's 1, and 2, and 2, and here's 0. Now, the graph of the first one, y equals 2x plus 1. When x equals 0, y is 1. When x is 1, that's a 3, so you get that point. So you can graph, right? This is y equals 2x plus 1. And if you flip this along this 45-degree line, then you get this, you get that, and you have. And this is y equals x over 2 minus 1/2. So this is a function, and this is the inverse function of it. And these two graphs should be symmetric along this x equals y or y equals x 45-degree line. That's what we learned earlier for the inverse function. For the trig function, of course, we know the 6 of them. Now we're going to learn the 6 inverse trig functions. Okay, first one. The function, the original function, we know y equals sine x. And the inverse function will be y equals sine inverse x. Okay, so this is the trig function. This is the inverse trig function, or inverse sine, or sine inverse. Now we know this graph, y equals the sine function. It looks like this, isn't it? Okay, right? And if you take the inverse of it, like a swap x and y, we cannot do this because we don't know how to do that. So we will see if we want to flip along the x y axis, what do I get? I get, if you flip along 45 degrees, this should be like the inverse function, but it's not, because it's not even a function. It's not going to pass the 45, the vertical line test, not 45, vertical line test. So the only thing when we deal with the inverse function, we have to pick one interval where x and y has a one-to-one relationship. In this case, we're going to pick from here to here. In this case, x and y has a one-to-one relationship. And what is that? That's when x is from negative pi over 2 to positive pi over 2. And your y will be from negative 1 to positive 1. Only in this little piece of the whole graph, it has a one-to-one relationship. Therefore, when you flip that, you get something look like this. So the graph look like Okay, here will be -1, here will be +1, and here is -pi/2, here's the +pi/2. Okay, so this is the graph of y equals sine inverse x. And now, what is the domain? It's very important. What is the domain? Domain is from -1 to +1. And what about the range? The range is from -pi/2 to +pi/2. All right, now here is we just flip it, right? Okay. Now something I want you to keep in mind, the difference between these two. This is an angle. Let's say you can put a 90 degree, you can put 100 degree, you can put a 0 degree, you can put pi/4, and then you take a sine of it. So we call this as a function value, and here's an angle. When you do the inverse function, this is an angle, and this is the function value. Okay, the original trigonometric function's function value. Okay, so let me tell you this. If I know sine 0 is 0, then I would know sine inverse 0 is 0. This 0 is actually this 0. Okay, and this 0 is the angle. So when you take the inverse function, you are your independent variable, or your input should be the function, the trig function value, and the output will be the angle. So you're looking backwards. Okay, you're looking for the angle, so that's why you use the inverse function. Now, sine pi/6 is 1/2. From this, I would know sine inverse 1/2 is pi/6. See, sine inverse of a trig function value equals an angle. Sine pi/2, sine pi/2 90 degree is 1. So sine inverse 1, which is pi/2, which is perfect because that's in the domain and here's my in the range, so it's perfect. What about this? What about the sine pi equals 0? Okay, what about the sine inverse 0? Not pi. Why not pi? Because your range has to be only between -pi/2 to +pi/2. You cannot go beyond that. See? You're not going to beyond that. So therefore, even I have this, but when I look at the angle, which give me the 0 as the sine value, it has to be 0. Remember this, sine 0 is 0. So this is very tricky, isn't it? All right, now, can you find sine inverse 2? What it says is this. You're looking for an angle, okay? And can you find sine theta equals 2? Can you find that theta? Of course not, because the sine is always between 1 and 2. Again, if you look at the domain is -1 to +1, you get 2. It's beyond the domain. So your answer is does not exist, which is impossible. Okay, so that's how you use it. All right, now question. What is sine inverse 0.8? Which means you're looking for an angle, sine of it equals 0.8. Do you know this angle? You don't. It's not easy to find out because we just, in the table that we have on the unit circle, we don't have that as the frequently occurred number, right? So I tell you what to do in this case. You're going to get your calculator. Sorry, this is your calculator. Do that. Okay. I am looking for an angle. The sine function value of that is 0.8. I don't know because I don't know what to do. So I will do sine inverse 0.8, but your calculator like this one, you don't have sine inverse. I know where to find it. Here. Did you see the second? So click second. You see a lot of a function change. Did you see sine inverse? Here, I might use this red color to point. See, sine inverse. Okay, so what you need to do is you do this. 0.8 sine inverse equal. That's it. You get a 53.13. Now, next question. 50. Let me move this a little bit so I can write. So I get a 53.13. Next question. Is this degree or radian? Did you see here is the radian, RAD, which means we save it. We're not using it. If you're not using it, the answer you got is degree. Do not forget to put a little degree sign there. It's very important, okay? You cannot just give me 53.13. I will not give you any points for that. So this is in degree, so you have to put a degree. Remember the range got to be from 90 degree, negative 90 degree to positive 90 degree. So that's perfect. This is 53.13. It is there. If you don't have that, your answer is going to be 53.13, but your range is only from negative pi over 2, which is negative 1.7 something, negative 1.57 something to positive 1.57 something. So that 53 is way beyond. Okay, so how do you use this to find the measurement in radian? Okay, you click radian. Hold on, let me just clear everything. You click radian. Did you see radian here? Which means I am using radian. I'm saving degree. I'm not using degree. Whatever shows here means you're not using it. Okay. So again, you do 0.8 sine inverse. Ding. You get that. So your answer is 0.9273. Either this answer or this answer. Either one is correct. But please make sure that if you're using degree, put a degree there. If you don't, then do not use degree. I know you're giving me this angle, the measurement is a radian. Interesting? Okay. Now, next question. What is sine of sine inverse 0.8? Okay. What is this? The sine trig function, inverse trig function, kind of like a cancel out. So I know the answer is going to be 0.8. So if I assume this is an angle theta, what do I get from here? I get a sine theta is 0.8, right? So if this is theta, is that right? Sine theta is 0.8, right? What about a sine inverse? Sine pi over 4. That would be pi over 4. The sine and the inverse go back to pi over 4. Make sure that it goes to the domain and the range. Match with the domain and the range. Don't go beyond that. Okay, so this is the first trig function sine. And then the second one is a cosine. Okay, again, if y equals cosine x, then my graph will look like this, right? Okay. If I only take the piece that has a one-to-one relationship, it's going to be from here to here. All right. And in this case, my x is between 0 and here is 2 pi, here's pi. And then my y is between -1 to +1. So what about y equals cosine inverse x? I flip it, the graph will look like this. So this is a 1, this is -1, and here is pi. Okay. And the domain is -1 to +1. The range is 0 to pi. In this, from 0 to pi, kind of like I get all the cosine values from +1 all the way down to -1. So that covers everything. This is the cosine inverse. So quick question. What is the cosine inverse 1/2? I ask you this question. You can assume this is a theta because after you take a cosine, you should get an angle, right? So cosine theta is 1/2, which means this theta has to be in this range from 0 to pi. There's an angle, cosine value is 1/2, so that theta is pi over 3. So the answer is cosine inverse 1/2 is pi over 3. Done. So see, cosine inverse 1/2 is here. That's pi. Here is pi over 2. So this answer is 1/2 pi over 3. Okay. And then quickly, we're going to go over all the others. Y equals tangent x. And the graph look like this, right? The graph looks like this. Okay. So can you find one small interval that x and y has a one-to-one relationship? Yes, we only need to do this. And in this interval, my x is between negative pi over 2 to positive pi over 2, not inclusive because I have a dotted line, so there's no equal sign. And my y will be from negative infinity to positive infinity. If I only take the red piece, I flip that along the 45-degree, I will have, here is pi over 2, here is negative pi over 2, here's a 0. Guess what I get something look like? Okay, so this is y equals tangent inverse x. And the domain is from negative infinity to positive infinity, and the range is from negative pi over 2 to positive pi over 2. Has to be parentheses, cannot be bracket. Okay. All right, now if I ask you what is the tangent inverse negative root 3, can you do this? Tangent inverse negative, here's a 0, negative root 3. So let's say this is a theta, okay? So the tangent theta is negative root 3. What is that? Tangent theta is negative root 3, which means theta got to be negative pi over 3. So that is negative pi over 3. So negative root 3 is negative pi over 3. Okay, so that's how you find it, how you find the inverse of a tangent. So we've done tangent. All right, we do the other three. There are three more. So y equals cotangent x, which the graph looks like this. Again, we only take this piece that x and y has a one-to-one relationship. In this piece, my x is between 0 and pi, and my y is from negative infinity to positive infinity, right? And then flip that along the 45-degree. I got this graph. And here is pi. So here is pi. Oh, I'm not very good. This should go through the middle, but that's like the horizontal asymptote. So this is y equals cotangent inverse x. Domain is negative infinity to positive infinity. Range is from 0 to pi. Okay, well, we do 3 more. Y equals secant x. Secant x come from cosine. Your cosine look like this, right? Right? So secant is flip it, so secant goes like this. All right. So if you have the secant function look like this, okay, I'm looking for one short or one interval that my graph has a one-to-one relationship. I'm going to take this and this. How is that? So we'll do here, that's pi. Here's 1, and here's -1. All right, now for this is a secant x. So that my x is from, could be here. So it's 0 to pi over 2, but not pi over 2, and pi over 2 to pi inclusive. And what about my y? Y is from negative infinity to -1 to 1 to positive infinity, isn't it? This is this part. Now the tricky part comes when you flip it. When you flip that, you flip that, like that, you get something look like this, you get that, you get it over there. So, I know it's not easy. So here is a pi, and here is a -1, so you get this, okay, and then this is a pi over 2. This is pi over 2. I should put a dotted line here. So here is -1, here is a +1, and then I go. This, when you flip, you get it. All right. This is a graph of the secant x. So the domain is very tricky, huh? The domain is negative infinity to -1, and from 1 to positive infinity. And the range is negative infinity, sorry, the range is from 0 to pi over 2, but just not pi over 2. So from pi over 2 to pi inclusive. So this is kind of like a tricky. Okay, very last one. We are going to graph y equals cosecant x. We're going to graph the inverse cosecant. Okay, so do you remember the cosecant comes from 1 over sine? 1 over sine looks like this. So cosecant looks like this, right? Okay, so cosecant looks like, okay, so here is 1, and here is negative. My graph is terrible. It should be -1 here. I'm so sorry. Here's a 0, and then this point is pi over 2, and this point is negative pi over 2. So I am going to use this. I'm going to use this piece and this piece. And that covers all the possibilities, but it also has one-to-one relationship. So that in this case, my x is from negative pi over 2 to 0, just not a 0, and from 0 to pi over 2. My y is from negative infinity to -1, and then from positive 1 to positive infinity. So when I flip, it's hard to I don't know, it is hard to see, huh? But when you flip that, x, y, and instead of that, I have a 1, negative 1, 0, and I have a pi over 2, and here's a negative pi over 2, here is y. All right, now when I flip this point, I get a 1 and a pi over 2, 1 and a pi over 2, solid, it goes that. And here I get a negative 1 and a negative pi over 2. And see, that's my graph. Scary, isn't it? This is the graph of y equals cosecant inverse x. And what is the domain? The domain is negative infinity to negative 1, 1 to positive infinity. And the range is from negative pi over 2 to 0, just now to 0, and then positive pi over 2. All right, so now you get the idea about how to graph all those inverse trig functions. If you have the original trig function, you have the graph, and then you flip it along the x y, x equals y, that 45-degree line, you can get the graph of the inverse function, inverse trig function. But however, you can only take the piece of the part that x and y has a one-to-one relationship. Otherwise, after you flip it, you don't get a function. So that's the hard part. All right, now the next thing I want to mention is we did a little earlier. We said, what is the sine inverse of sine, let's see, pi over 3? And the answer is pi over 3. And what about the sine inverse root 2 over 2? So this is the function value, sine inverse of that, you get an angle, which is a 45-degree. Sine of that is, again, is root 2 over 2. So now you see they are the inverse function of each other, only in certain interval, or only in certain range or interval. So that's what happened. That's why we need it. However, we might have a different situation. We might, if I ask you, what is the cosine of sine inverse 0.8? That's a tricky part. I'm asking for the cosine function of an angle. This is a theta, okay? And I know sine theta is 0.8, but I'm asking you, what is the cosine theta? Do you know how to find that? And do you remember that we have sine square theta plus cosine square theta equals 1. So if a sine is 0.8, so it's 0.8 squared plus cosine square theta is 1. So this is 0.64. So cosine square theta will be 1 minus that is 0.36. So cosine theta should be 0.6. Cosine theta will be 0.6. It's not very easy to see, to get it from here just by look. It's hard to tell. But if you change this, make that to be theta, use another symbol to represent that, this question becomes much easier. Okay. All right. So that's how you work with this called composite trig functions. Let's see. Let me ask you another one. What is the sine inverse tangent pi over 3? This is easy because the tangent of pi over 3 is root 3. So I'm asking for what is sine inverse of root 3. Tangent pi over 3, that's a 60-degree, is root 3. Can you find the sine inverse of root 3? What is root 3? Root 3 is 1.7 something. Can that be a sine value of a function? If this is a theta, can you find sine theta equals 1.7 something? No way, right? So this one, the answer is does not exist. Okay, so let me give you another example. Can you find, let me see this way. Can you find uh, tangent, let's do this. Let's see, cotangent of sine inverse negative 1/3. What you can do, there are all different ways to do it. Let me tell you the calculator way. Sorry. Calculator. It doesn't matter you're using degree or radian. I can just use either one. I'm using radian right now. So I got a negative 1/3. So it's negative 1 divided by 3. Hey, sorry, negative 1. Oh, 1. How do I do that? I do negative 1. Oh, I do that. Divided by 3. Right? So this is a negative 1/3. And I take sine inverse of it, equal. So I get that. And then I do cotangent of it. So I have, right now I'm on the second. So I get to go back. And then I do tangent, cotangent of it. I don't know, there's no cotangent. So I do tangent and then I do reciprocal. So tangent of it equal. And then I do reciprocal. 1 over equal. There you go. I get a negative 2.828. So you can have that. Okay, that's one way to do it. Use the calculator. There's another way to do it. Is remember sine is y over x, so which means you have sine 1 y over x. Sine is sorry y over r. So it's a y is negative 1 and r is a 3. So it's like that. So that's a 3 and negative 1. That's this angle. Okay. So what is the cotangent of this angle? This angle's sine is negative 1 over 3. So this is negative 1, right? Or 1. The length is 1. So cotangent will be x over y. I need to find x. I know y. Y is negative 1. So can you find this? Yes, that is, let's say this is x. So x squared plus 1 squared equals 3 squared. So x squared equals, this is 1, this is 9, so that's 8. Therefore, my x is the root 8. And my y is negative 1, isn't it? Here, negative 1 and the positive 1 squared are the same thing, so that's why I didn't write it. So this is a theta. So cotangent of theta is going to be x over y. So that is x over y. Okay, so it's a negative root 8, which is negative. If you use a calculator, if you use calculator to do root 8, oh, I don't know what happened. 8 square root, you get a negative 2.8284. Did you see that you get exactly the same answer? As long as you give me the answer either like this or this, I will think that's the right answer. That's good to know. Okay, so that's another way to figure things out because we have x, we have r, we have x, y, r. We use that relationship to find out this composite function. However, be very, very careful. Again, be very careful with the range and the domain. Okay, so I think that's all we need to know for this inverse trig function.